it onto the code. Clear or not clear? Okay, now make some assumption. So now these are the assumptions. So it means that there is some memory, and that memory has some value of 0x4000. This is the address. At that address, what is stored? A. So A is stored here. Any question? So A is stored here. Clear? So this A is now stored, and we do not know the value of A. A can have any value. So this is our assumption. So A is now stored at an address 0400. Any question? Again, now we have C10, who is pointing to an array C. Who is pointing? Which is R2. Do we know the address? No, we do not know the address. So it can have any address. So R2 is now storing C, and C is pointing to some memory location here. What will be stored here? Help me. C what? Help me. C0. Then C1 and blah 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 until what? Please remember, we do not know the value of C. C can have any value. So okay, now if you look at here, what is this address? Can you see what is this address? No. C. What is the next address? C plus 1. What is the next address? Last address? C plus 10. And what is 10? 10 is the index. Clear or not clear? This clear? So this is actually now this is our problem at hand. Now, if you look at here, this is very important. This is very important. Because can we do any operation? Okay, which register have been used? Okay, now we have R0. So we have R0 has been used. Then which register have been used? R1 has been used, so we cannot reuse them. Is there any R2 here? Yes. Where is R2? Yeah, R2 is also used. So we have R0, R1 and R2. So it means which register can we use? R3 or R4 or R5, it is your choice. But we can use R3. But now the problem is that, okay, now for this C10, please remember, it is on the left hand side or right hand side? Left hand side. So for that, which instruction should we use? Store. But now the problem is that if you do that, and this is the same index. So if you are using 3 store instruction, efficient or inefficient? Inefficient. So what we can do, we can temporarily, please look at, so we can define some temporary register. We can define some temporary register. And please remember, this code that is I am solving it here, the board may be different from the code that is there in the thing. So that code may be different. So what I am going to do, so instead of this, can I replace this C10 with some temporary register R3? Yes or no? Because the operation on register is efficient, like faster or slow? Faster. Because operation on register is faster. So can I replace this R3 with what? C10 with what? R3. So this C10 will be replaced with what? R3. This C10 will be replaced with what? R3. And this C10 will be replaced with what? R3 and then R2. And in the end, what should we do? Store R3. Because please look at the approach. Okay, now if it has been C10, it has been C5 and it has been C2, we cannot do that. But since we are using the same value in all of this, so we can, because please remember, operation from the memory is faster or slower? Slower, because it is off-chain. And operation on register is faster or slower? Faster, because it is on-chain. Clear? Okay. Now this is how I will do it. Okay. Now we want to write the program. So what we are going to do? So I can make it here. So this is part 1. what should be my first instruction? If R0 is equal to 5. The first instruction. So this, okay, please remember. Okay, now what I'm going to do, this is what I'm going to do. So this is actually line 1. Can I write line 1? Okay? So basically then I can write, this is my starting address of the program. L1. What instruction should I use? Okay, now add. But now since we have indicated R3 here, but now we can use some temporary register R4 for the computation. So what should I use? Add R4. No. R0 hash minus 5. So what will be now the value of R4 here? It is R0 minus 5. There are two conditions. If the condition is true or the condition is false. Okay, if it is equal to 5, where should we jump? C10. So now for this C10, so this is my line 1. Please remember. So this is my line 1. Please remember, this is important. This is okay. In the C++ we can have different statements. So how will you do? So this is my statement 1. This is my statement 1. This is my statement 2. S2. So I can call this S1, not line 1. S statement 1. S1, S2. What is this? Which statement is this? S3, S4. Then what? S5 and then S6. Any question? Clear? Okay. Now we are in S1. We are comparing R0 with 5. If it's equal to 5, where should we jump? S2. So it means that if it is equal, BRZ. So BRZ. It means that if R0 is equal to 5, where should we jump? S2. So we should jump to S2. Any question? Clear or not clear? Okay, now we have S2 here. S2. Okay, we will do it later on. I will do it later on. But if this condition is false, there are two possibilities. If this condition is true, we will jump to S2. If this condition is false, we will jump to what? The next line, we will jump to S3. Okay, we will do it later on. We will do it later on. I will do it later on. But if you jump to S3, so we are comparing R0 with what? 9. Which instruction should I use? Help me. Add. Very good. Add R4, R0, hash negative. Okay? Now we are comparing it with negative 9. Okay, now smaller than. What should we use? BR what? BRN, BRZ, BRP, what? BRN. We should use BRN. And if it's there, BRN, if this condition is true, where should we jump?
S4.
S4. So BRN, S4. And then I'm putting S4 here. We'll do S4 later on. Now there are two possibilities. If the condition is true, I will jump to S4. If the condition is false, where should I jump?
S5.
S5, which is your else. So I'll jump to S5 now. I'll jump to S5 now. When we jump to S5, what is the value of C10 now?
4.
4. So C10 is equal to 4. What should I do now? Help me. Anyone? So R3. What should be the value of R3 now? 4. How can we make it 4? No, how can we make it 4? Huh? And so basically, can you see here? Now we go to the S5. So now this will go to the S5 and then definitely this is not S5 because if it's S, it is not S5. It is actually S6. It is not S6. Please remember, this is S, so this statement will execute. This statement will execute. All the conditions are false. So C10 is equal to what? 4. So if we see to S6, so this condition is true. So we need to store a value of 4 in which what? R3. So we can see S6. What should we need? And R3 S0. Because we need to initialize R3 to 4. What we need to do? Help me, next line. Add R3 S4. And when this is done, we go to what? Which line? S7. This is S5, this is S6, and this is S7. We comes to S7. And what is in S7? C10 is equal to C10 multiplied by what? 2. So C10 is equal to C10. So it means, second C, what we can do here, C10 is equal to C10 multiplied by 2. So it means we can multiply R3 with what? 2. Clear? So what we need to do? So S7, so this is my S7. And if it's S7, so what we can do? Help me. Add. No, 1 minute. So we can do add R3. We are adding R3 to R3, so it will be 2R3.
Professor, before that, in S6 you need to store the value in the limit, right?
Which one?
In S6.
I know. I will do it. Clear or not clear? Okay, then please remember. So whenever we have this R3 is equal to R3 and then we have some exit. So this is my exit here. And in the exit, okay, so this is my S7. In the exit, we need to store the value. So basically this is so basically one minute. Add R3, R6, yes. And then what we need to do? So because R3 is equal to R3 multiplied by 2. So we need to store that in the memory. What we need to do? Help me. STR, yes. We need to store the value of what? R3. So this is my line number. Okay, now make it line number 6. This is S6. This is S6. And now this is S7. STR R3. Who is pointing? R2 is pointing to, yes. R2. And then what? Hashtag. And this is the last statement. What should be the last instruction? Track. Clear or not clear? Okay, but now, what is now missing here now? The implementation of S2 and the implementation of what? S4. Okay, if you look at the implementation of S2, what we need to do, load? 0x400. You got it or not got it? So we have some data section and we have some code section. This is my code section or data section?
Code section.
Code section. So we need some data section. And in data section, what we need to store in the data section, what we need to store? The address of what?
Yeah.
A. So basically what we need to do. So what I'm going to do now. So I'm not writing it here. So now this is my data section. Okay. So now we can say, okay, then we have, this is my data section now. And then I can store what? Address of A. What is my address of A?
4000.
0x4000. We got it or not got it? Okay. Now, this address of A please remember, this address of A, so we need, so can we, if you look at here, this is my mem. How many times it has been used? 2 times. So can we load this into some temporary register? Yes or no? Which register can we use?
R5.
We can use some R5. So okay, even we can do it before the loop. Before the if statement. So what we can do? What we are doing it? So you can see LD, and we are doing it one time. LD, we can use some register R5. And what should I write here? Help me on the right hand side.
Address A.
The label, address of it. When we have R5, so at this point of time, what will have R5 now contain? R5 will now contain A. So basically, now we have this memory 0x400. What we can replace that with? We can replace it with what? R5. And what we can replace this one? With what?
R5.
Yes.
Why not LDI?
LD. Man, the problem is that when I have the R5 address of A, so this is the address of A, this will load. Yeah. LDI, you're right. You're right. Because LD will store what?
400.
0x400, and LDI will store the content. You're right. You know, he's thinking. Very good. Any question? Because if you are using LD, so R5 will not contain 0x400. It will, if you are using LD, it will contain 400. We are not interested in 400. We are interested in the content of 0x400. Yes. Any question? Okay. Now we have R5. Now what should be there in R2 S2? Help me. C10. C10 is mapped where? R3. What should we write here? Add what? Help me. Add R3. Then what? R5. Then what? R1. When it's done, where should we jump? S7. We should jump to S7. What should I write here? VRNZP. What? S7. So it will jump from here to here. Got it or not got it? Because this is an unconditional statement. This will be executed in any case. Okay, again. Now we are going to S4. Okay, now when we go to S2, let's assume this is my S2 now. This is S2. S2 is done.
You put the BRNZP on the.
Oh, sorry. So BRNZP, what? S7. Yes, you are right. Now we want to implement S4. What should we do here? Not. Okay, so where is S4? Not. So we can reuse. So now we can do what? Not.